Hello. So this is a video about this data in Google Sheets and creating some scatter plots and getting the right line of best fit or curve of best fit for that data. So this is from this idea here, from this handout we looked at, that a linear function, if you plot x versus y, will look like a line. If it's a power function, log versus x versus log y will look like a line. And for an exponential, x versus log y will look like a line. So we're going to see how that looks, what that looks like in a spreadsheet application like Google Sheets or Excel. So there are 4 sets of data here. This is the first set, in and out 1. We're going to select that data and look at it. So once it's selected, we can do insert chart. Okay, I don't want to look at the data like this. I want to make it a scatter plot. So I'm going to go to setup, chart type, scatter plot. And this is also not quite what I want. I want my x-axis to be the in and the series to be the out. Now it's showing the data appropriately. This is the inputs. This is the outputs on the y-axis. It looks like a line already. It looks linear. I can't look at the residual plots easily in Google Sheets or in Excel. You would have to manually create the residual plot, and that's kind of a lot of work. So how do you add the trend line in these? So under Customize, Series, you can scroll down to find trend line. The type, there's many types you can pick, just like in the calculator: linear, exponential, polynomial, logarithmic, power, moving average. You can do linear. Change the label to use equation and show the r-squared. Note if I tried other shapes like exponential, the r-squared value gets worse. If I try power series, the r-squared value 0.914. For linear, it's 0.829. That's interesting that power series looks better. There's no reason to think this is a power series. So that's interesting. So use linear unless there's a really good reason to think it shouldn't be linear. So even though power looked better, linear is appropriate here. If we could look at the residual plot, we might see a hint more, but I generate this data to be linear, so linear is fine. So that's one of the 4 charts. Let's now look at the second set of data. So when I select, I'm holding Shift to select these 2 columns. I'm going to insert my chart. Again, I have to set up the data here. This is I want a scatter plot. And I want my x-axis to be my inputs. And I want to look at the outputs. I don't want the inputs to be one of the series I'm looking at. So that's the data I want to see. Now this looks like a curve, so a line's not appropriate. But is it exponential or is it a power series? Well, I can look at the log scale for the y-axis. On these things, typically you wouldn't do a transform of the y data or the outputs. You would just change this from a linear scale to a log scale. So you can do that pretty easily. Double click the y-axis, and there's this option here, log scale. Does it look like a line? If it does look like a line, that means it's exponential, but this doesn't look like a line. So now we're going to look at the log of the x-axis as well. I have double click the axis, and I'm going to scroll down to log scale. Now this does look like a line could fit it. That means this is in fact a power series. So I'm going to add the trend line. Note a line on this log transform for x and y doesn't look like a line at all. It looks like a curve. I want to use the equation, show the r-squared value. So a line gets a 0.901 r-squared value, but we don't want a line. We want a power series. So now the power series looks like a line on the log transformed axes. Now you could leave it like this, or you could now take it off of log scale to see the original linear scale that we're so used to. And that's the second data. Now I'm going to look at the fourth data, and you can not use this video for the third data because the third data is the kind of maybe the trickiest. So the fourth set of data, I'm going to copy in and out 4. I'm going to insert the chart. And I got to change this. My x-axis should be the in numbers. The series should be the out. I don't want to look at the input as an output series. This is my, it's not a line chart, it's a scatter plot. This data is a very steep curve. Is it quadratic? Is it a power series? Is it exponential? Well, first thing we're going to do is do a log transform of the y-axis. When we do that, and before I click this, what I'm thinking is if it looks like a line after I do this, that means it's exponential data. It does look like a line, so this is exponential. So now I'm going to add the trend line. Exponential. Show the equation, show the r squared. Now you could undo the, you could look at it on a linear axis again, undo the log scale, and there you go. So again, what's the point of all this? The point is using spreadsheets, very useful skill to have for data science, for science classes, for other math classes, and just in general, it's useful. Also, this looking at things on a log scale or a linear scale is kind of the more maybe a more common way in other contexts. You'll see this to determine if data is exponential. Because if you look at it in a log scale, it should look like a line if it's exponential. So this is about how you can transform data. Now this is just touching on like a topic that's pretty complicated. So main takeaway, if you kind of understand that if it looks like a curve, you could potentially do some log transforms. And if you just do it on the y-axis, it looks like a line, it's exponential. If you do a log transform on both axes and it looks like a line, that means it was a power series. So please do this for the third set of data in and out 3. Figure out, is it a power series? Is it exponential? Do the curve fit? And you will share that Google Doc as your submission. Thank you.